when b is smaller than 0. Reason the geometric model holds for finding number that complete the square of the expression x squared minus 12x. Explain. So for instance, we have this x squared. So this represents the x squared here. So we can represent here. One side is x, other x. So geometrically we can write with the x squared. So this is the square. But now for this x squared we are taking minus 12x. But let's write this form now a little bit differently. This minus 12x, let's say, is a rectangle. But let's divide this rectangle into rectangles. 6x, so two rectangles to represent geometrically, minus 6x. So we can write this way. And now this was x times x. This was the blue square, which is the x squared. And we are taking now minus 6x. And this rectangle here, we can write here is a 6, and here is x. And so this rectangle, we can write 6x units square. We are taking from the x squared. But now we want to take this minus 6x. To take this minus 6x, it would be this piece here, this rectangle. But if we are taking this rectangle, we already cut it away or took it away, this rectangle, from the x squared. So it doesn't exist here. Now this piece here, this piece of what was, for example, 6 times x, and this side, for example, is 6x. So now this piece already is taken. But whatever is this piece here, we are putting to take up the remaining of the x squared. And we put in here. But as we see here, this is 6, this side is 6, and this side is 6. The square was 36 units square. That's why this 36 units square we are taking away from the x squared. And now the remaining region, because we took minus 6x, now the remaining piece here geometrically represent this x squared minus 12x, geometrically represents this region here, what is remaining, the region with the blue color, x squared minus 12x. But now here was a x and here 6. We can write here now. And the area here was a x, and this side was x. We were taken here 6, and this region from this position to this distance is x minus 6, because the 6 is taken away. But same thing is here, x minus 6, so this region. So that's why we write in here x minus 6, and here x minus 6. But now we are looking here, for example, does it satisfy the completing square method? We know to complete the square we use the criteria b over 2. What is a b here in our case? In our case, a b is a 12. And 12 divided by 2. 12 divided by 2 is equal to 6. And the other criteria is b over 2 square. What is going to be b over 2 square? So b over 2 square is going to be equal with a 6 square, because b over 2 is already 6, but b over 2 square is a 6 square, in which case is equal with 36. So we have 36 here. And now to complete the square, when we have in this case x squared minus 12x, and to complete the square here, we add in 12x. We add in the b over 2 square, which it happened to be plus 36. And now we already created perfect square trinomial, and which is equal with the x minus b over 2, which happened to be 6 square. We are converted into the perfect square binomial. And the geometrical interpretation of this example holds.